Hi, I'm Craig Rowland, founder of Sandfly Security. Welcome to today's presentation where we will be talking about protecting Linux against SSH key risks. In today's talk, we're going to be going over some slides to describe the problem, as well as live demonstrations of the attacks and live demonstrations of how to detect those attacks using Sandfly's agentless endpoint detection and response product to help protect your Linux enterprise against these serious threats. Now, in today's presentation, we're going to be covering the major ways SSH is abused, but there are some other ways that it's abused as well that we don't have time to cover in today's presentation just because of the length it would take. So I encourage you to read the white paper that goes along with this presentation because it goes into many of these topics, and reach out to us if you have any questions because we're happy to answer those as well. For the talk today, I think it's important to understand that we have a really simple agenda. Essentially, we're going to be talking about the benefits and risks of SSH. We're going to talk about the SSH key attack vectors that are very common in terms of Linux intruders and how they're going to move about your network once they gain access. And we're going to wrap it up with some conclusions and hopefully some tips you can use to help secure your systems against this type of threat. So first of all, let's understand what SSH is by looking at the benefits and the risks, because everything has a benefit and a risk. First of all, you should understand the history of SSH is that it replaced Telnet. Telnet was a legacy protocol. It was completely unencrypted. Telnet allowed you to access systems as an administrator or as a user to do your day-to-day work. The problem is, like I said, unencrypted. This means that an attacker could watch your session and steal information as it was traveling across. And more importantly, they could watch your login and grab your username and the password you use, and then they can immediately have access to your account with those stolen credentials. So it was a very big problem. There were some other advanced attacks as well, where they could actually do session hijacking and insert malicious packets into an active Telnet stream to actually cause that system to execute commands. But it had all these problems basically because it wasn't encrypted. SSH came along and solved this. It gave us full encryption of the entire data stream, and it also added on a strong authentication layer, helping us get rid of passwords and move over to a more secure public-private key authentication system. Now, SSH keys are more secure than passwords because they're harder to steal. A password, once you steal it, it can be used in many places, and that password hash is present on many different systems. So those systems that they get broken into, there's many opportunities for a password theft to occur. The SSH keys are a bit different. You really need to have the SSH private key in order to enable that same type of attack. And it's generally a little bit harder for an attacker to get a hold of a private key versus a password. So this was a big step up. The third thing it did is it gave us ubiquitous way to access all these Linux devices. So it replaced Telnet, like I said. So that means that SSH is available to access not just big clusters up in the cloud, but even small devices running on your network today, such as IoT and embedded systems that many enterprises have scattered about. Now, the other side of this, there's some risks with SSH. That full encryption that protects your communications from being snooped on, it also protects the attacker. So if you have network monitoring devices, traditionally, they might be able to inspect those sessions and see what was going on if someone's doing something up to no good. But now that they have that encryption in place, they can no longer do that. So that actually protects the attacker. Second thing is that public-private key that was an improvement over passwords. It actually opened up a new mechanism where a stolen key could suddenly provide very wide access to many systems, which we're going to get into in this demonstration today. But just understand that a stolen key presents a very big risk, just as a stolen password does, and in some ways might be a little bit worse depending on your situation. Finally, the last thing about SSH is I call it the most easily deployed backdoor on Linux. Because it is ubiquitous and offers all these features and benefits, it's a great way for an attacker to gain access and maintain access to systems. It gives you a full encryption to protect their communications. A stolen key allows them to move around. They can insert backdoor keys to hang around, and it can even forward packets, which means it can bypass firewalling and segmentation devices that you might have set up in your network to protect how network traffic's moving about. So it has some really unique benefits from a backdoor perspective. Now, the main risk that we're going to be talking about today with SSH would be stolen keys. Now, how does this work? How's a stolen key work? Well, there's a very simple playbook. First of all, the attackers are going to compromise a host through a variety of mechanisms. Doesn't matter what it is, log4j, misconfiguration, user does something dumb, whatever it is, they're going to get access to that host. Once they get access to that host, they're going to search it for private keys that are lying around. Now, if those keys are encrypted, it doesn't matter. They'll download the keys and they'll run a brute force attack against it using Hashcat or John the Ripper. And many times, because people are bad at picking passwords, those encrypted keys are going to get cracked and people are going to find out what they are, and the attacker's going to have that key. Once they have some private keys, you're going to use the history and other log and configuration files that the user has to find out where that user is logging into. And then they're going to take that private key and they're going to try to log into that new host. And chances are very good that key is going to work. Now they're going to gain access to that host and they have their lateral movement. Once they get on that new host, they just repeat the process. They search for new keys, search for the history and logs that users connecting to, connect to the system, search for new keys, and they just do this over and over and over again. And before you know it, an attacker can actually spread very quickly across a network. And during that time, they've collected a bunch of keys to move across those systems. So now it becomes a very, very big problem. So why are they going to steal the keys? Three main things. First of all, stolen keys are very hard to detect. It's not like your wallet. Like if I came and I stole the wallet from your pants, you'd reach in your pocket, you're like, oh my God, my wallet's missing. You know physically that the wallet's gone. A stolen key is just data. If they make a copy of it, you have no idea that the key's been stolen. It's a very quiet thing to do. Second of all, stolen keys frequently give very wide access. Users do not generally make a new key for every host they log into. They'll make one key, and then that public key side they'll distribute to all the systems they need access to. So that means if I get access to that one key that they have, I'm going to have access to all their systems. And this is really important too with a lot of machine-to-machine automation, because a lot of machine-to-machine automation actually has privileged access to many systems, such as a backup account or a configuration management system, for instance. And finally, the last thing here, stolen keys are silent. And what I mean by that is essentially that as long as that user doesn't go in and start rocking the boat, a traditional EDR is probably not going to see them there. And many times attackers do not need to obtain root access to achieve their goals. They can often achieve it just by maintaining a regular user position and just stealing and accessing the data that that regular user has access to. They can get just about everything they need. And again, it's very hard to see that they're happening if you're not watching SSH keys and who's using them. So let's go steal some keys. Now we're going to jump into a live demonstration here in a purpose, but the live demonstration is doing something very simple. I'm going to show you the script I'm actually going to run. Here it is. We're basically going to do a find command against the hard drive, and we're going to look for any file named ID_RSA, which is the default key name that SSH uses. There are more sophisticated scripts out there that do other things, but just to understand right now, that's what we're doing. Second of all, we're going to look into the temp directory and the dev.shm directories, and we're going to see any files that might have text in them indicating they might be a private key. This is something that you can do if you think that private keys might be renamed and you want to make sure you're not missing anything. And these directories have a particular risk, which I'll talk about as we get into the demonstration about why we're looking in there for them. So let's go ahead. I'm going to drop to the terminal now, and we're going to steal some keys. Okay, I've dropped on our victim host, and our victim host today is a Raspberry Pi, and this wasn't an accident. Sandfly works perfectly fine on embedded devices as well as conventional servers, so it's very important to keep an eye on these things. In particular, IoT devices are frequently targeted by attackers because they're so poorly monitored. But unfortunately, a lot of embedded devices can also contain really sensitive information and a lot of information that can be used to help enable lateral attack, and that's exactly what we're going to see happen here. Now, if you recall in that slide, I had a script called SSH.sh. And I'm going to look at it here again. So under here, we're going to do a find for this key name here, ID_RSA, which is the generic default name used by SSH. And then we're going to look for these strings happening under the temp or the dev.shm directory, which is the RAM disk on Linux. And this is going to give us something really interesting. So if I run that SSH command, in a few seconds, we come back. And sure enough, under home Pi, we found an ID_RSA. I found a root key. So now I have a root user key. I found another key in Varspool News, which was interesting. We'll talk about that later in the demo, but just keep that in the back of your head for now, because you'll find that pretty interesting. And finally, here under the temp directory, we found a directory called config back. It has some keys here called backups, Nagios, and Ansible. And finally, under the dev.shm directory, we have something here called Pi user. So let's take a look at some of these. First of all, I'll go to the SSH directory for root. I do LSAL. Sure enough, yep, I got a private key here. So what this means is that I can log on to this host as root whenever I want to in the future, even if they patch the hole that got me onto this box to begin with. And again, it doesn't matter how they got on the system. It could be a myriad of ways. Just understand that now they're going to leverage that initial access to start stealing keys. So now I got a root key. And under the next thing we do under the Pi user, let's see, home Pi, go to .sh, And sure enough, we do an LCL here. Okay, now I got not only that initial key I found, but there's some more surprises here. ID.get, looks like I have access to a Git repo. RSA2, who knows what that is? I'm gonna take it. ID RSA old, just because it says old doesn't mean it doesn't work. So I'm gonna take that key as well. And so now we have some more keys to add to our collection. Now the last two places we want to go to is, we'll go to /temp. Under SAL, again, we have this config back directory. So I'm gonna go there. And under this directory, sure enough, again, I have these keys. Now, this is actually a real world example. We have seen configuration management systems leave behind large numbers of private keys for whatever reason. These could be custom scripts or something, but for whatever reason, a script has gone haywire and left really sensitive information in publicly readable areas. In this case here, I can see it's readable by everyone. This is the read flag for world readable as well. It's also owned by the backup user, which means that this was likely done by some type of backup script. This is kind of a common thing in machine-to-machine scripts that they sometimes make mistakes, but this is a really big mistake because these keys here likely are going to give me access to some really privileged accounts on these various systems. Now, the last thing, if you remember, there's a key under dev SHM, and under here is called PyUser. And I could check it here, and sure enough, it is a private key. I can see that now. Now, why would this be important? Because dev SHM is the RAM disk on Linux, and the RAM disk on Linux is cleared out every time the system reboots, which means that it's a favorite place for malware and intruders to do activity because if the system reboots, it deletes the fact that they were there. All their evidence disappears. So the fact that I have a key sitting in this directory makes me think I'm not the first person to visit this box. This person might have been visited before, and that attacker might have dumped or used this key in some way. Now I'm going to take the key anyway, just in case. But you understand now, I kind of can see these keys. Now the next thing you want to understand is, well, what are they going to do with it? So if I go to the PyUser directory here, if you recall correctly, under that SSH directory, that they had all these keys, and I might want to find out, well, where are they going with them? Well, first thing I'm going to do is I'm going to grep for the word SSH under, let's see, /home py bash history. And here I see immediately two systems that you SSH to, this one here and one here called get. So now I have something really interesting. So I'm going to write down, somehow make a note of these systems are accessing. And then a lot of people don't understand that SSH, you could put a config file in that allows you to use abbreviated names that connect. So under this directory here, it's called config. If I do a more on the config file, I could see here, yep, this is 192.168. This is the ID key that works. And here's that host get that I saw before. Here's the address it resolves to, and again, ID get. So now I have a user account for possibly get admin access to a software repository. So that's another way I'm going to access systems. Another way that you can access and find out where people are accessing is just to look at the known host file. So here I would look at the known host file for this user. And for this user here, this is what's called a masked address. So SSH can be set up to mask the IP addresses that you're connecting to. But sometimes down here, you can see it might not reveal everything, right? So under this system here, they turned off masking, and now I can actually see the full IP address. So if you look at the known host file, this can often give you some more information about where they're connecting to. So these are just some of the areas that a user is going to use in order to find out kind of where they're using. So if we look at the attack pattern so far, what we see is I've identified multiple users that have SSH keys. I know where those SSH keys are. I went into those directories. I found additional SSH keys that weren't found in the initial search. I also found keys under the temp directory and dev SHM directory that are very valuable. And then I used the history file from those users and the config file from those users to find out more systems to attack. So now what I'm going to do is I'm going to go into the Sandfly console. I'm going to show you what it looks like from our perspective as a detection side to help give you an alert to find out that this system is going to be having some big trouble that you need to look into. Okay, so we're now on the Sandfly console. Let me show you what Sandfly is going to show you on this system, not from the attacker point of view, but from the defender point of view, that this system likely has some trouble that you need to investigate. Now, what's interesting about Sandfly is that we have the ability, like I said, to work across all systems, anything from a decade old up to modern devices. We did scan this device as a Raspberry Pi. It doesn't matter to us. It's an embedded device. If it has SSH access, we could probably get onto it. So we scan the system here, and in this demonstration portion, we're only going to focus on the private key risks and stolen key risks that I talked about before. I'm going to tell you a bit about that. So first of all, we found several basic alerts that when we scan the system, these are what we call a dormant attack. So this is different from what we would call an active attack. An active attack is something happening in memory right now. A dormant attack is something that's happened to the disk, but not necessarily running. So SSH keys are a perfect example of a dormant risk. They're just sitting there waiting to be abused. They're not actually being abused at that moment in time. And this is something that a traditional EDR might entirely miss because they're not looking for this. Sandfly, however, we do look for this. First of all, a couple things. We'll just start at the top. We found a private key unencrypted on the system. And in fact, we found multiples of that. So we've already checked this system here. We've identified multiple keys that we found under user directories that have some type of unencrypted state. We can also look for encrypted keys as well that are lying around, but for today's demonstration, we're just going to focus on the unencrypted keys. So when I click on this key here, I say, look, the home directory for Pi, SSH id.get is an SSH private key without a passphrase. So again, now I know that, right, this user has a private key, it's on their system, and it's unencrypted. This is telling me that this is potentially a high severity issue that we need to look into. We would have all the information about that over here, as well as the raw result information that's going to show us more details. The details would be when that file was created, who owns it, flags about it, hash information, and inside it too, we show you information about the key itself, that what we see. But the main thing to understand here is that we've started to identify a large number of keys owned by users, private keys that are on this system that we probably want to look into because they are unencrypted. It's a very, very high risk keeping an unencrypted private key around. If they're encrypted, your policy might be, well, that's okay, we're going to leave it alone. Unencrypted private keys, though, are almost always a significant problem you need to look into. The next thing we found here were unencrypted keys in the temp directory, and I showed you that already. That config back directory, we identified the RSA, the Ansible backups, and the Nagios key. Again, I already showed you that from the command line, but again, we're showing it to you from the detection engineer point of view, what you would see. We've identified these keys. We said, hey, these are owned by a user in the temp directory. It's kind of an unusual place to have them, and they're unencrypted keys hanging in a temp directory. We think you need to look into it. We're not saying it's necessarily the system's been attacked, but what we're telling you is this is a good way to get your system attacked. The last thing here that we did is we found these private keys under the dev.shm directory. And again, we found that dev.shm Pi user key. Again, very, very suspicious. We have a full description here of why that key is a problem here. We even say keys in dev.shm directory could be left over from malware and exploit attempts against the host. So again, we're just saying we don't know why this key is here, but we do know it's a private key. It's in a very sensitive place on the system that's frequently used by malware. We think this needs to be investigated by you and your security team for something that might be going on. But this is kind of what we see here in terms of private keys that are very likely to be leaked and are very likely to result in some type of stolen key access to begin moving across your systems. So now let's going to go ahead and we're going to jump back into the slides and we're going to talk about our next topic around how keys are going to be abused further. Okay, we just talked about the risk of stolen keys under SSH. Now let's go ahead and talk about kind of its flip side, which is backdoor keys. A backdoor key is really simple to understand. Essentially, it's laid out right here. I drop a key in and you have no idea whether or not that key is from a legitimate user or not. It's just another line in an authorized key file. And many times users can put new keys in, admins can put new keys in. The keys might stay around for a long time. They might be old, they might be stale, they might be a temporary key that for some reason was never removed. You just don't know. What you need to understand, though, are three things. First of all, it's a very common tactic for a backdoor key to be left behind because the intruder knows once they put that key in there, it's very unlikely it's going to be removed, and it gives them instant access back onto that system again, no matter what patches were applied to try to kick them off from their initial access mechanism. Second of all, backdoor keys can persist for a very, very long time. If the attacker drops the key and then doesn't come back to stir any trouble up, you might find the keys are actually getting part of your backups now and actually can be restored onto a system that you thought was compromised. You might be bringing the attacker's key back into the box, or You might migrate that system to a new host, and all of a sudden you find out that the attacker's key has been migrated along with all the data and is again now active on that new host. Finally, the keys are just difficult to see. The authorized key file, again, each line is random cryptographic text. Humans are very bad at looking at random text and making hide nor hair of it. So that key could sit there very quietly, again, as a dormant type attack, which we discussed already, and can really persist and be a problem for a long time, and a very quiet problem you might not know is there. So how and where are these going to be used? Okay, they're often inserted into active users in order to blend in. You got user Bobby. Bobby gets an extra key added. Bobby's not a terribly sophisticated user. He doesn't know the key is there, or maybe he sees it there, but he doesn't know. Maybe the admin did it for whatever reason. It's there. Admins can get keys added onto them because a lot of times you might have multiple people trying to log into the same account. Now, all of a sudden you find out that the web admin or database admin, or even worse, the root user has, 23 keys on them, allowing all these different people to log in. Happens a lot. The keys can also be put on default accounts that nobody's monitoring. So how many people really look at the news account or the UCP or the LP account? These are account defaults that have been around since the early Unix days. And they can get a key put onto them with some additional tricks in order to hide access activity from admins. And finally, the keys can be inserted through a network service attack. A vulnerable web script can be used to drop a key onto a web user that now allows them to log in. So there's a variety of ways that these backdoor keys can show up on a system and persist for a very long time. So let's go ahead and drop to the demo system here, and we're going to take a look at some of the problems associated with these keys. So we're back on our victim system here, and we're in the root user directory, and we talked a little bit about this already, but let's go back to our Pi user because they're the ones of interest. So if I go to the SSH directory, and again, I have the authorized key file, which is a very common way for people to maintain access with SSH. So if I look at this key file here, authorized keys, I just see it's full of just text and text and text of keys. If I just look at it, you can't tell from a human perspective what key does and does not belong there. Even worse, if I just look at the access time on that file, it just tells me the last time it was accessed. It doesn't tell me which key was added at that time, because I could put a key anywhere in that file. It might be in position number 1, it might be in position number 7, it might be in position number 13. You don't know. So the date alone isn't enough to help you there. So there's a lot of problems with trying to maintain visibility onto the authorized key file. And there's a lot of places where this can actually lead into big trouble. Now, the other thing we saw, if you recall correctly, is the user on this system. We had a user called news, which was a default user that had a key. So if I go to the news directory, user, and I go to SSH directory, I see that they have an authorized key. Now, this is a default user, so why do they have an authorized key? Again, a lot of admins and a lot of security teams aren't watching these accounts, so you don't necessarily know that this key was even added. This key can remain there for a very long time, and again, can be very, very easily moved with backups of systems between different hosts as well. So we want to look into that as well. But just understand that right now we have a couple problems. I have an authorized key file with a whole bunch of entries in it that I can't make hide nor hair of, and I have a default user that has an SSH key on it. So let's go ahead back to the Sandfly console, and I'm going to show you what it looks like from the Sandfly perspective so we can give you some organization and details and information so you know exactly what's going on with these hosts. Okay, we're back from the terminal where we reviewed kind of the big mess that is authorized key files, the idea of being able to look at all these things and tell hide nor hair. It's very, very tough to do. So we're going to show you how Sandfly handles this. First of all, we did a scan of the system and we got some alerts relating to this backdoor type key activity that we kind of want to unwrap here. First of all, we scanned the system. We found that we got an alert on this sbin no login. So understand that the file sbin no login is a special binary that's used to basically say if a default user or an account with that shell logs in, it essentially says, can't log in, bye, and it kicks you off the host. Pretty simple to understand. So all the default accounts on Linux will have this typically assigned as their shell. What we're showing here with this alert is that someone has renamed a bin bash shell as the no login. So essentially now what that means is someone with a no login shell actually has a real shell and they can log onto the host. And if you remember, the news user has that. So that's of interest to us. The next thing we said is we got an authorized key zone violation. Basically, we have two users here. They're showing in violation. I'm going to discuss the SSH security zone feature in a second, but just know this. We've identified the user news. They have an authorized key. We give it a human readable name, detergent everybody devotedly. And we're saying this key was not allowed on the host. Someone has added this key, and now this is something that we need to look into. The next thing we saw here is that a default user, in this case, again, that news user has an authorized key file. And essentially what we're saying that this is a system default account and normally shouldn't have any SSH keys to log in. So this again is that example of a dormant attack. And this is something you need to look for. This is something that Sandfly is really good at doing. We operate kind of like a guardian angel looking over your shoulder. And this type of stuff, we look for you because we know that a human's just not going to see this type of thing. So now we've identified several different problems on this host. We know that a no login shell has been renamed. We know that some keys have been added because they're not part of the security zone that we permitted on this host. And finally, we know that some default users have had authorized keys put on there that normally shouldn't have it. So how are we going to bring all this together? We bring it together in a feature we call the SSH Hunter. The SSH Hunter is our ability that when we log into a host, we collect all the public keys we see being used by users, and we start indexing them ourselves. We know who's using those keys, where those keys are, when those keys showed up, and we look for other security attributes of those keys that indicate they may or may not be related to a compromise. So in the overview of the SSH Hunter, we give you the dashboard information about what we see, where we see it, security zone information. We see new keys that might have been added, so you can investigate keys that might have been added on the host. But we also allow you to pivot and look at these keys from multiple perspectives. First of all, we have the key view. Essentially, you can view a key. I could click on it. I could see at that point, what host that key is on. I could click down here and see all that information. I could see what users are using that key and so on. I then have the user investigator. So again, I could click on a key. So for instance, here's the root user. I could see immediately what host and key entries. I could see all the hosts that user has access to. I could see also, again, what key entries that they have that are going to permit that user to log in. Then finally I had the host view. And this allows me again to see a host, what users have access to that host, when they were added, and so on. So these are the three different views. It gives you control and organization of these keys. So you're starting to get a better idea of how these things are going to affect your enterprise SSH security. But the thing we just added recently was something called SSH security zones. A security zone is basically a group of systems that we've tagged, and we said this group of system is allowed to run this set of keys. If any new key were to show up, we want to know about it. So essentially, this is how we protect keys from being introduced into an area where they shouldn't be. For demonstration, I have my production and development areas, and then I have something here called the internal SSH zone, which you see is red because it's in violation. If I click on this, I see these are all the hosts that are allowed access. These are the keys I said are allowed access to this zone. And over here, I could see that this zone's in violation. So when I click on it, I see my system over here, and I could see the Sandfly victim. And I could see these are the keys that are on this box. These two keys with these red shields are in violation. This key is what's called a duplicate, which I'll talk about in the end of the presentation. But for now, just understand that that's not the key we're concerned with. These keys here, I could see has two users on it. This zone has a Pi user that has a new key that was added to it. And this key over here, detergent everybody devotedly, is being used by the user news. If I click on the user and key entries, I could see again all those users. So the news entry here, I could see it's entry number 1 in the authorized key file. This one over here, if I click on this, I could see that this Knickers Wildlife germless is in entry number 1, and down here, these red, these are those duplicate keys I discussed. But I'm able to see very instantly what users were added to these systems that don't belong there, and especially to what keys don't belong there. So getting back to this situation, another thing I can do by looking at this host is I could say, right, well, I don't think these keys belong. This key, for instance, Knickers Wildlife germless, this is being used by the user Pi over here. I don't want that key anywhere. So what I can do is I can actually now ban that key. So if I click ban on that key, we are now going to mark that key as banned, and any host it shows up on is going to have a special flag on it. Here, if I refresh this now, you can see that the status has reverted to banned key in use. And again, I can go to my host investigation and I can see here that this Sandfly victim has a banned key. Any other host is also going to show that on it. So now I can mark a key as banned if it's suspicious. I can now immediately see, okay, what other hosts are using this key? So again, I now have context and awareness and actionable data that I can use to help isolate and contain a lateral movement attack that might be happening. In this case here, a rogue key. So that's kind of a quick overview of how the Sandfly SSH Key Hunter works from that perspective. Now, the thing I talked about also is the duplicate keys. So we're going to go back to the slide presentation again. I'm going to show you that last bit of information. Hopefully that helps you out because that's kind of also a common problem we see with SSH. Okay, the last problem we're going to talk about specifically are duplicate keys. Basically, duplicate keys are where two or more of the same key exists in an SSH authorized key file. That means if I delete one of those keys, but I leave the duplicate there, that key could still allow log into a box. Now, why is this a particular problem? Well, it's a problem because a lot of times these keys can get into a state of not being in sync. So let's say I need to have user Johnny log in. I put their key in and they can log on, but another admin says, oh, Johnny wrote me, says he needs to be able to log in. So I put the same key in twice for that user. Now, later on, if I come and I say, well, let me remove that key because I don't want him logging in anymore, if the duplicate still exists in that file, that key still works. Okay, so that's the problem. So this is sometimes done by human error. It is sometimes done by key management systems that insert a key, but later, for whatever reason, don't remove it properly. So they just insert another key that's a duplicate of it. Well, the last thing we see is actually malware that's kind of dumb. Some of the dumber malware will insert a backdoor key and keep reinserting that backdoor key over and over and over and over and over again in order to try to get on it. So let me go over to the screen here and I'm going to show you a bit about how this works. So over on the Sandfly console, we've again scanned the host. And to keep our things under focus and control, we're just going to show you the one alert that generated on this system here that says a policy violation that we found duplicate keys. And we said here that the user Pi has keys that are duplicates of each other. And this could be a result of automated key control, push duplicates, or an accidental duplicate. Or it could sometimes be related to malware. So again, we're giving you an alert that this is actually going on. We show this as well inside of our SSH Hunter. We have a special icon over here called, you see here, this is key means duplicate. So if I click on this key, I can see here again what host it's a duplicate on. I can see it's over here and it's for that Pi user. If I go over there for the Pi user, I can see it has 19 copies of that key. If I go over here to the host entry, I scroll down here, it's going to show me all the keys that are duplicates. So here I can see countries 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way down to 19. Now, what this basically means is that I would suspect this would be an automated key management system that's gone off the rails a bit. We have seen this happen. So this is something, again, I would want to go in and clean this up and find out why it's happening. Maybe that key management system's having a problem handling these keys in this host, but for whatever reason there, you just need to keep an eye on this because it's a common issue. So that's a duplicate key issue. We do see it in enterprise deployment, so it's something to look out for. It's just another thing that Sandfly does to help you out. Now let's go back to the slides and finish this all up. Okay, so we went over some pretty significant SSH risks, such as stolen keys, backdoor keys, and duplicate keys. We don't have time to cover some of the other risks. I could probably talk for another 2-3 hours on the particular problem, but just know that we have some things here. First of all, excessive and orphan keys. These are keys that are abandoned or over time just old. They're just sitting around. Nobody gets rid of them. Weak keys are keys that are using old, obsolete algorithms, or maybe key bit lengths that are too short, like 1024-bit RSA keys. Malicious options and forwarding options. You can actually get an SSH key to run a malicious option when a user logs in, and that option could run a command that could do something really bad news to the system. So it's just something that else is out there. These are all things that Sandfly looks for. I encourage you to look at our SSH white paper that goes along with this presentation. We go over some of those risks. I think you might learn a few things by reading it that might surprise you. But again, it's here that Sandfly is going to help you because we look for these problems for you. So essentially, in conclusion, watch your keys. It's really straightforward. Stolen SSH keys are a major threat on Linux. Unencrypted keys are a really, really big problem. Private keys lying all over. The backdoor keys are effective, and they can lie around for a very, very long time, as discussed, and they can lie around on accounts that nobody's paying attention to. And finally, the duplicate keys are a problem we see typically with management errors, but they can allow old, stale, or keys you don't want hanging around to remain on systems that you don't know are actually there. So it's something you got to look out for. Finally, we do have, other problem, the SSH key, passwords and other risks, they still kind of remain, again, beyond the scope of today's presentation, but just understand that there are a lot of other issues with SSH that Sandfly can help you monitor, and we encourage you to check it out. So I'm Craig Rowland. Thank you so much for watching me in this presentation. I hope you got something out of it. Please let us know what you think, and reach out with any questions or comments. We'd be happy to hear from you and help you out in understanding the SSH key threats that might be affecting you and how Sandfly can help. Thanks again for watching. I appreciate your time today, and goodbye.